Okay, sample problem 16.2. Label each of the species in the following equations as an acid, base, conjugate base, or conjugate acid. Okay, so we're going to label each of the species as one of those four. Well, it's not that hard. I'm going to leave the states of matter out just again to have room here. Try to space these out a little bit. This one's reversible. And then you get F minus and NH4 plus. Okay, so let's try that one first. So again, based on our lecture notes, what we do is you combine one of the reactants with one of the products that differ only by an H plus. Those two differ by H plus. The NH3 differs from NH4 plus by an H plus. That's how they differ. Now, the one on the reactant side is going to either donate or accept. So does this accept an H plus, meaning does it have more H pluses at the end or before? It does before. So that means that it's the donor. So that means it's the acid. So this is called a Bronsted-Lowry acid. Now, the F minus is going to be the base, but remember on the product side, we call those conjugates. So if HF is the acid, F minus is going to be the base. So this is a conjugate base. Meaning that if you considered the reverse reaction, that's the arrow going to the left, F minus would now be a base. Okay, so it's called the conjugate base because it's on the product side. NH3 has 3 hydrogens. NH4 plus has 4 hydrogens plus a positive. That means the NH3 gained a proton, gained an H plus, so that makes it the acceptor, which makes it a base. And then the NH4 plus is a conjugate. If it's on the product side, it's a conjugate, and so it's going to be the acid, right? Remember, you can't have an acid and an acid on one side. You can only have an acid and a base on one side, and the same goes for the product side. If one's a base, the other one's an acid. So the NH4 plus, from the perspective of the reverse reaction, the arrow going to the left, the NH4 plus is donating an H plus to become NH3, so that would make it the acid. So products are conjugates. Conjugate, conjugate, base, acid. Let's try B. B is CH3, COO minus. By the way, that's called the acetate ion, like acetic acid, the active ingredient in vinegar. And then you become CH3, COOH, and OH minus, right? Okay, let's take a look at this one. Again, you make pairs. I'll pair these two off, and then pair those off. And then you just determine which one gained the H plus, which one donated the H plus. The acetate ion, this one right here on the left, it gained an H plus, right? It has more H pluses, so that makes it the base. The acceptor is the base. The water lost an H plus to become OH minus, so that makes it the acid, the donor, right? And then on the product side, just do the opposite, because they're going to be conjugates, right? When we're talking about products in acid-base chemistry, we call them conjugates. This one has an H plus, now it doesn't, so that means it donated. It makes it an acid, conjugate acid. The OH minus has 1 hydrogen, now it has 2, so that makes it the base from the reverse reaction perspective. And there you go. So that's identifying acid-base, conjugate base for acid-base chemistry. Bronsted-Lowry. This is what we call Bronsted-Lowry theory.